So what you see here is something called a Minitab output. There are so many computer programs devoted towards statistics. Some of them are extremely powerful. Minitab is just kind of one of the intro-level programs, and it's a little bit user-friendly, but there are some much more powerful ones called SAS, which is literally SAS, Statistical Analysis Software. R is a very popular statistical software program where you can program it yourself. It's very much like programming languages that you might see otherwise, but it's geared specifically towards math. And what you do with Minitab is you input a set of data, and you tell it what you want it to do. So here they told it to describe grades. And what they've got is you have the sample size, which is your n, mean, median. Don't worry about true median, standard deviation, and standard error of the mean. We look mainly at mean, median, standard deviation, min, max, quartile 1, and quartile 3. So in order to determine the interquartile range, what would you do? Subtract Q1 from Q3, what do you get? 16. Now, the thing about this data is we are just talking about test grades, and test grades don't really have labels. It's just a score, it's just a number. So that's the only reason why we don't have a label on this. Interquartile range, min, median, max, all of those things should have labels if it fits the data. So if we use this stuff here, are any of my points outliers? It's kind of an interesting question to ask, right? Can you figure out what would qualify as an outlier? How do I know if something's an outlier? Right. So the IQR is 16. What's 1.5 of that? 24. So if I subtract 24 from 68, what do you get? 44. Notice how my minimum is less than that? That means I'm going to have an outlier. I don't know how many, but I know I have at least one. What is 84 plus 24? 108. My maximum is within that fence, so that means the only outlier that I'm going to have is going to be something on the lower end. So at least the minimum is an outlier. So we don't actually have to have exact values for all of my values to determine if there is an outlier. If I have the minimum and maximum, I can determine, do those guys fall within my fences? And if they don't, then that means you are going to have at least one outlier. Okay? Yes? 1.5. 1.5, and you can see here, so you take quartile 1 minus 1.5 interquartile ranges, or quartile 3 plus 1.5 interquartile ranges. Yes? Oh, dear God, no. I would need to see what you have here. I would need to see 68 minus 1 times 16 equals 44. And I would need to see 84 plus 1.5 times 16 is 108. And then I would say the minimum is less than 44, so it's an outlier, but the maximum is not. Okay? We all right on that? It's how we can use interquartile range to determine outliers without all of my data points. All right, so gotta love this problem. Moose burgers and McTofu. Yeah, I don't know if I'd ever want to eat at a place called McTofu. Not a big tofu person. Though I don't think I'd eat at a Moose Burgers place either. Though I've heard it's very good. I don't know. Whatever. 5 number summary. What is the, let's talk about Moose Burgers. What is the minimum for Moose Burgers? 110 quartile 1. 123 median. 133.5 quartile 3. 144 and max. But all of those are in terms of dollar bill, y'all. So McTofu, minimum. 100, quartile 1, 110, median, quartile 3, and maximum. Okay. We then get to use those to build box plots. And when we build box plots with the intent of comparing, you always want to build them so that they're going to be parallel to each other. That means if you're doing them vertically, they're going to be stacked side by side like this. If you're doing them horizontally, they're going to be stacked side by side like this. So you're not going to do one on top of the other. You're not going to do one next to the other. They're going to be as close to each other as possible so that you can compare. And when we're doing box and whisker plots, it's really not about the, either, like if you're looking at it horizontally, it's not the height of the box. If you're looking at it vertically, it's not the width of the box. That's just there for us to see it. But what you're looking for your parallel box plots is going to be something like that. Now take a close look at what we have here. I don't have every single value listed on these box plots. I have numbers that will set the scale for me. I probably would have gone down to 125 so that I could see where that ends, and I probably would have gotten up to 325 or 350 even because of that 360. But you have a general idea of scale. I have a label on that scale because this is not a frequency. That is actually your values. Those are your salaries, or you could say dollars. And then I have each individual box plot labeled as which restaurant it is. So I have Moose Burgers and McTofu. And you are more than welcome to abbreviate those guys. I do not write stuff out. But you want to make sure that when you abbreviate, you can tell where it comes from. Like MB, obviously Moose Burgers, McT, McTofu. If you're going to say A and B or 1 and 2, you have to somehow identify which group is which. And then we have our labels for restaurant. Now this guy here is an extreme outlier. So it should be denoted with an asterisk, not a box, or a dot, or a circle. Okay? Extreme outliers should be asterisks. Asterisks? Asterisks? I have no idea. Multiple extrasos. All right, so do we have questions on the building of the box plot? I typically look at my space and I say, gee, what's a better use of space, vertical or horizontal? For this one, either one, because you have those ridiculous margins on the printout, I probably would have done them printed the way it should have been. Probably would have done it horizontally in the middle. So, whatever. I don't care about that. You also don't need to individually label numbers on each of these minimum, maximum fences, any of that stuff. It should line up with your scale, so you should be okay. Okay, questions on that? All right. So, when we want to write a few sentences comparing distributions, this is what today is all about. Comparing is the same thing as describe. It just uses slightly different language. So, when we describe, what do we need to include? Shape, center, spread, and outliers or anything that's unusual. So, shape. How would you describe the shape of Moose Burgers? Does anything like jump out at you and say weirdness? Okay. Generally symmetric. Do we see modes in that? That's a box plot. You can't see modes in box plots. That's what sucks about them. You can see quartiles really nicely. No idea what my modes are. So all I get to say for Moose Burgers is it's generally symmetric. What about McTofu? There is a huge outlier with that one. Otherwise, I mean, if I ignored that outlier up there, I mean, it seems to be a little bit skewed. Maybe you could say skewed to the up, which is right. Larger numbers skewed right. So you could say there's a slight skew right here. I mean, you could probably, I don't know, that's so close it's hard to tell. But with this, we have an extreme outlier. So that really does change the general shape. Okay, so I would say Mooseburger appears to be generally symmetric, and overall so is McTofu, but McTofu has an extreme outlier, which skews the data. That's my shape, my center. What would I use to describe centers with this? Median. Now here's a really big point. If one of your data sets is skewed or has outliers, you have to describe both data sets with medians and interquartile ranges. You're not going to all of a sudden compare mean to a median. Does that make sense? So if you have one guy that's skewed, you have to use the same descriptors for both. So for center, I would describe medians. And what kind of language could you use for your medians that uses comparative language? What is the median for Mooseburgers? 183.5. What about McTofu? 120. What's true about those numbers? Yes, they're different. How so? There you go. Mooseburgers has a higher median salary at $133.50 to McTofu's $120. Notice here, I am talking about the groups. I am giving the values for those centers. I'm also giving context. The salary is $133.50 versus $120, and I'm throwing in comparative language. Mooseburgers has a higher median salary than McTofu at $133.50 versus $120. So listen to that. We know we have shape, center, spread, including anything unusual. But when we're talking about center, you want to give me the values for center for both of them. You want to give me context. And you want to use some sort of comparative language. Okay, spread. What can you tell me overall looking at the graph about the spread of the data? This is not an in-depth question. Look at it. Spread. Spread. What would you say is true? McTofu has greater spread. I might say that the interquartile range for Mooseburgers is 21, which is very similar to McTofu's interquartile range of $22. But because of the outlier, McTofu has a much greater spread or a much larger variability. Yeah, overall range. But we don't normally, I want to make sure that you understand that when we're talking about range, the focus is on variability. How much does it change from what your expected average is? Okay? All right. Oh, let's see the words. Blah, 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 blah. And then overall, general, who makes more money? Mooseburgers overall tends to make slightly better salaries. Okay? So it says, which restaurant pays the higher average salary? We said Mooseburgers. And if I were to, sorry. Oh, because it said average, yeah. Mooseburgers has the higher median, but if I were to calculate higher average, who has the higher average? McTofu. Why is that misleading? Yeah, they had not really even an extra employee, but one dude was ridiculous. Sally. She's like Sally. Sally must be the boss's daughter, right? Or she's got something on the owner and she's blackmailing, and I don't know. So At which restaurant would you rather work? McTofu or Moose Burger, aside from tofu and moose? Based off of salary, where would you rather work? Moose Burgers? Of course, I will never forget Phil Choi a couple years ago. When he did this question, guess what he said? McTofu. He said, I'd be the one making the outlier pay. Just a little bit. I will never forget that. He literally wrote down, I would rather work at McTofu because I would be the one making the crazy. Sure. It wasn't really what we were going for, but if he fully believes he is going to be making that money, okay. Maybe he's got something on the owners. I don't know. But really, with statistical justification, we really are looking at those ideas of median or mean, or where do you think the most people make their salaries. Okay? Hey, guess what? That's pretty much everything with comparing. So comparing is still going to be talking about using our descriptive language. Shape, center, spread, and unusual features. Where we have to make sure that we give values where we have values. No, we don't have a number that goes with shape. But we do have numbers for center and for spread. So you must always return those numbers. And you need to make sure above everything else, context. Because without the context, everything we do in here is completely pointless. Okay? And then the only thing that we're doing differently is the idea of comparative language. Now, there is one more type of a graph that we don't really see too often, but they have it in our curriculum, and it's something called an ogive. Ogive. It's not an ogive. It is pronounced ogive. Now, another term for an ogive, which kind of makes a little bit more sense to folks, is something called a cumulative frequency plot. And what that means, cumulative means everybody that was before it. Frequency, how many people. So if I'm looking at this point here, that means the cumulative frequency, there's about, I don't know, let's say 15 or 10% of the people are at or below 30. 40 goes a little bit higher. Let's say 16% are at or below 40. I could say, I don't know, 35% are, extreme close-up, at or below 35%. Are scores percents. So here we go. 57% are at 60 or lower. So when you do like your SATs, your Ohio standardized tests, all of those standardized testing that you do, and they return to you what percentile you're in, that's telling you what percent of the students scored at or below. Not just below, but anybody who's equal to you as well. A cumulative frequency chart. We can use the cumulative frequency charts to gather information about our data. We can actually easily find things like minimum, maximum, quartile 1, quartile 3, median, interquartile range. All of those come back because the maximum is the highest point, the minimum is the lowest point. So the minimum corresponds to probably something like a 29, and my maximum corresponds to, looks like a 90. Your median is where 50% of the data is at or below you. Understand? So I look at 50% of the data, I scroll over, and I see about where would I hit. And so looking at that, 50% of the data would be at or below probably a score like, 58, 57, something like that. So this is how we find our maximum and our minimum and our median, specific locations. If I wanted to find the interquartile range, what would I look at? 25% and 75%. So that's all I'm going to do. I'm going to say quartile 1 is about 25%, quartile 3 is about 75%. Now, if it doesn't hit a nice little spot on your graph, that's okay. You are still going to drop down from where it does hit to find the values that it corresponds to. So quartile 1, I would say that's about, 48. Quartile 3 looks to be about 66. So how would I find my interquartile range? Subtract those values. Okay, that went too fast. Extreme. Okay. So again, in an ogive, you want to make sure that you've got the lowest point as the minimum, highest point is the maximum, and for your percentiles, you find the percentile on the vertical axis, and you just string straight across where it hits the graph, drop straight down. So I could answer the question of, if you want to be in the 80th percentile, in order for you to have scored better than or as good as 80% of the students, I'd go over here and that'd be about a 70. Okay? They're nice for that. And when, at least it's been a long time since I've taken a standardized test, sometimes they actually show you the graph of how people did in an ogive. At least they did back when I remember from middle school, they'd have this little graph and they said, this is where you are. And then spelling, I was always on the lower end. Everything else, I was on a high end. Spelling, I don't word good. It's not funny. Okay, so these are some of the more difficult questions that we have to face with given data summaries. And so these are each separate problems. I am giving you summary statistics. These are all the summary statistics that we really focus on. What could you tell me about the distribution of that data? And if I ask you to tell me about the distribution of the data, what am I asking you to do? There's nothing to compare this to. What's another word for what can you say about the distribution of the data? And describe. And when we describe, what do we need for describe? Shape, center, spread, any outliers or unusual features, and always in context. So go for it. So when you're looking at A and B, there's all sorts of different ways that you can think about describing this. I'm a very visual person, so I would just sketch the box plots. And then I would put on any extra information that I could. Like I would state where the mean is and try to think about what that means about my data. Okay. Okay, so let's take a look at what I did for these. Now again, I'm very, very visual, so I turned A and B, ooh, that's kind of light, into box and whisker plots. What I also did on here, something that you're not quite familiar with, there are some graphs that when they do box and whisker plots, they'll actually incorporate the mean into it. And there's a couple of different ways that they do that. Either they do that with like a little caret on the top saying, hey, look, this is where the mean would go. Or more commonly on statistical software, you'll actually see where it looks like the box has been pinched. And wherever it looks like your box has been pinched, that's where your mean is. And so if you look at this, my mean is to the right of my median. Without anything else, if I just went back and looked at this and said mean and median, and notice that's a pretty big difference between the two of them, I can say my data is going to be skewed. Since the mean is higher than the median, it's skewed right. So if you wanted to do that without looking at a picture, that's how you compare your median to your mean. And when we calculate our fences, wherever they may be, what did you come up with for your fences? When you did IQR times 1.5 and subtracted that from Q1, what did you get? Should have been... You're supposed to get a negative number, right? And is the minimum less than that negative number? No. And that's going to happen sometimes. That's okay. It's okay to have a negative fence measurement, even if it doesn't make sense in context. That just means that since my fence on the lower end is going to be negative, I do not have outliers on that lower end. When I do my interquartile range times 1.5 plus Q3, what do you get with that one? 2297.5? Is my max within that? It is not. So that's why I'm going to have, I don't know how far out, this is where my fence would have stopped. I don't know where my data is in with that, but I know no matter what, I'm going to have this outlier, and I know it's actually an extreme outlier. Okay, so that's going to tell me that if I were to describe this, I would have said shape, skewed right, with a center, my median, at, what was the median for that? $705, because we're talking about salary, with a, since it's skewed right, from $510 to $1,225. And I would say there appears to be an extreme outlier with the person making the maximum salary. Okay? Whereas for the second set, if I look at my B data, my mean is 114.2, my median is 114.5, and my range goes from 100 to 134. So that tells me that these guys are really close to each other, especially in context of what your whole data goes through. So because those two are so close to each other, I would say that my data is roughly symmetric without even drawing a picture. But you could draw a picture and put it together. And even though it's roughly symmetric, I don't know where it goes to. I do know that my maximum is again an outlier. Okay? Only this time we're talking about highest temperature. So I would say degrees Fahrenheit, because that's what we're talking. Fahrenheit and Celsius, huge difference. What? Highest temperature was 134. I don't know where that is. 32, well, that's going to be like Arizona, in the middle of the desert, Death Valley. Yep, 32 different states. So, and the highest temperature being 100, that's probably not going to be Alaska. Just what I think. I could be wrong. Maybe it's reached 100 in Alaska before. Lord knows it's been more than that here this year alone. Okay? And for the very last problem on that page, this is one that a lot of people get mixed up on. They said first block had 25 students with an average of 85%. Second block had 29 students and an average of 80%. To calculate the overall average is found by taking the sum of each of the individuals and dividing by the total number of individuals. So this 85 was taken by dividing some number by 25. So if I take 25 and I times it by 85, I'm back to that whole sum. Same thing with the second block. If I take 29 times the 80, I'm back to its whole sum. And because to find average, I don't care about the individual little pieces, I'm just talking about the overall sums. Add those two together and divide by my overall total. So you get 82.315%. Anybody get that answer? Couple folks? Does anybody have questions on this? Because you can do this in all sorts of different types of problems. I could say the average salaries. They do it a lot with average scores. I could talk about average weight, and then all of a sudden, one more person comes in. I could say, oh, the average weight among 40 people was 185 pounds. But all of a sudden, we get another individual in, and that individual weighs 110 pounds. Annoying, skinny person. She's like... And so I can figure out the total overall average by saying 40 times 185. Add in the next person, and then divide by the new total of people, 41. Okay, that's a very, very important example thing that you need to do. All right. Gotta love the fact that you don't have that. Oh, there it is. Shows up next. I don't know why I have it animated. But here is our Intro to Stats class, midterm. Think about what kind of data that gives you. Think about, are you going to have any outliers? And this is the way the AP exam loves to work. Without actually giving me any actual values, interpret this for me. Stats focuses a lot on interpretations. Looking at A, would you expect the mean to be higher or lower than the median? What do you think? My median is at 39. Let's put it this way. From my median to my minimum, how far do I go? That's all I need. That's beautiful. Absolutely perfect. You would expect it to be lower because the difference between the median and the minimum is much bigger than the difference between the median and the maximum. So that's going to tell me that my data is going to be skewed left. When you're skewed left, it pulls your mean that direction of your median. Absolutely beautifully said. If I look at the difference between my median and my minimum, that's going to be 22.5. Difference between median and maximum, that's going to be like 9.5. So it is much more spread out towards the lower level than it is towards the higher. Okay? Everybody clear on that? All right. Were any of my scores outliers? You're saying yes? I really don't remember. I didn't look at the answer. Yeah? No? Okay. When I do my IQR, I get 11.5, and I find my fences to be 14.75. Is the minimum less than 14.75? No. I get my upper fence to be 60.75. Is my maximum greater than that? No. And the only work that I would need you to what you get from quartile, what your lower fence and your upper fence is. And then you would say min and max are no outliers. Easy peasy lemon squeezy. Okay? Questions on that? Again, today is just all about practice. So, go for 3. My goal for today is to get a frappy in here. I don't know if we'll make it or not, but we'll try. When we look at these problems, these are very common test or quiz questions, as well as AP questions. Okay? So, with the AP, they love to give you things like this where they'll have 3 different pieces side by side, and it's not that the problem itself is difficult. It's just that you have to make sure that your answers are complete, concise, clear, and in context, especially with that in context piece. So if we look at this, which class had the lowest cumulative college GPA? Juniors. And then you would say, what is that? About, it's going to be, you could say, you could say 1.5, you could say 1.6, you can say 1.55. I know it's difficult to kind of gauge exactly. But you need to be able to tell that across them all, when we're talking about lowest cumulative GPA, that's these values. So who has the highest median GPA? Sophomores. And what would you kind of guesstimate that to be? 3.25, 3.2, 3.3. As long as you're generally close to that, great. If you said it was 3, I would say no. If you said it was 3.5, I would probably say no. Okay, so you want to make sure that you're fairly close. Now, which class has the largest range for GPA? Juniors. And what would you guesstimate that range to be? 2.4? Let's see what we said. Look at you go, 2.4. So if you're having trouble looking at it that way, you can always just kind of like grab it and move it to like where it would be on an axis, just kind of help you measure it a little bit better. But again, I'm not going to sit there and say, ooh, you rounded out to the nearest hundredth and you got a different answer than I did. Or, ooh, your answer is off by 0.1, you fail. I'm not doing that, okay? Which class had the most symmetric set of GPAs? Seniors? We in agreement on that one? And so skewed would be sophomores. Okay? Because if we look at this, this has the smallest range from median to either the maximum. We have the longest edge out there. How are we doing with that? Now, one more. I don't think we're going to get to the frappy. I know we're not going to get to the frappy today. But hang on to that because that's a very important problem. Had you guys already done this one? Some people? And I will tell you right now, in an AP test, they would not say, be sure to talk about shape, center, and spread. They would just say, compare the two distributions of women's heights. When we're comparing the two distributions, let's start first with shape. So generally speaking, it's not perfect. We don't live in a perfect world. Generally speaking, what are their shapes? Look at this one. Roughly symmetric and unimodal. So when we have an actual histogram, you want to make sure that you talk about modes. So this is unimodal. I mean, you might be able to make the argument that it's slightly skewed left. I would accept that. I would also accept roughly symmetric. It's not perfectly symmetric, but it's kind of close. What about the European women? Unimodal. I can understand an argument towards slightly skewed right. What I'm going to say here is they're both roughly symmetric. I mean, there's not like anything that's saying, oh my God, look at how skewed and weird and everything this data is. I would say both the heights for the US women and the European women are roughly symmetric. Center. Where would you put the center for the US women? Pretty much 164. Where would you put the center for the European women? 162? Maybe 163? So I would say they're both roughly centered, close to 164 centimeters, 163 centimeters. We okay with that? So I've used center, I've identified where that center is, and I've used comparative language. They are both about. You might want to say, well, I think the European women might be slightly higher or slightly taller, but it's roughly the same. Spread. What would you say for the spread? Are they the same? No? Who's bigger? The US has a bigger spread or the Europeans? So this goes from 152, We're counting by the same stuff, but this one goes up to 180. So I would actually say that the European women, this is saying the heights for the US are more spread out. I would have flipped that. Am I missing something? Okay, so I think that's backwards. So they're saying that the scales are the same, but there's something that could be improved so you can compare distributions. If I want to compare distributions, what do you think I could do to make that easier? Box plots, because you can like squish them together, right? You can also actually do histograms squished together. Like you can actually do an overlayment type of thing where you can kind of see through them and see one and then the other. You can do it so that you have one box for the European women right next to it, the box for the US women, and kind of stagger them over there. But somehow making it so that the y-axis, if you look at that, did you guys notice that? X-axis was the same. Y-axis was clearly different. So you could make those the same is probably going to be the biggest selling point here. Now, we're not going to get to the frappies, but I do want to make sure that you guys understand that there are the summarizing quantitative data and then there's the describing quantitative data. So you actually have a total of 6 little sets of problems that are due Monday night. Please make sure you get that. I will be posting the stuff for the class data project. That will be due on Friday. Quiz next class. Have a great weekend.